Hello friends, Shivansh this side, and today I'm gonna show you an innovative way of visualizing nuclear reactions with thermodynamics. So let's start. So first of all, process of making of a from constituents to nucleus. mm, Energy released in this process is known as binding energy, EB, right? Energy released in this process is known as binding energy, and let's say it's delta FH in our thermochemical ways, and delta FH is negative of EB. Okay, because delta FH is energy content difference, right? And energy released is taken as negative in delta H. So delta FH is negative of EB. Okay, and now one more thing is that when we see in difference of mass terms, like of course this is a nice thing to know that mass of this is less, that's why the reaction is spontaneous, and delta mc square is delta fh. Delta mc square is fh. And how can we explain is that way, in way like mass final, like mass what we get minus mass we what have, and the energy content is due to that mass, and difference in that energy content is energy which has gone. Okay, like this is a energy profile diagram of a nucleus A, and this is energy profile diagram of a nucleus C, like initial things. So difference in this mass is the energy which has gone. Okay, and EB is a not a nice thing, but delta FH is a nice thing because it shows whole energy content. According to thermodynamics, delta H is energy content of thing, energy content of product. So delta FH is basically difference in energy content at two stages, right? Difference in energy content in two stages, and let here energy content be mc square. So mnc square minus mc c square, mn minus mc into c square. This is delta fh. So these are two definitions which you must learn, I should say, proceed forward in this video at least. Delta fh is minus eb and delta mc square is delta fh, and logic is simple. Delta eb is energy release, delta fh is positive of thing, negative of that thing. Delta mc square is difference in energy content, and this is measured by delta fh, and it gives obvious relation that delta mc square is minus of eb. Okay, now let's consider a nuclear reaction. For example, let's start by alpha decay, that x gives y plus alpha. Now its delta is delta RH plus Q. Q is energy released and delta RH is difference in a heat content. So this is true. This is a thing you will agree. And also mass here, total mass here must be less than this one. We will prove it later on as well. Now as far I can see, there is nothing like entropy here. So for reaction to be spontaneous, delta G must be 0, implies delta H also must be 0, less than 0. Less than 0. That means Q must be positive for spontaneous reaction. Okay, and I think this analogy is very nice thing to carry on if you are comfortable in thermodynamics and not in nuclear reaction like I was. Anyways, delta RH is negative of Q. Now let's write heat delta RH in terms of delta FH. Delta RH is what? Delta FH alpha plus delta FHY minus delta FHX. Now we know that delta FH is negative of EB, minus EBH alpha minus EBHY minus EB alpha minus EBY minus, not minus, plus EBX. I hope this step is clear, I guess. So delta RH is minus EB alpha minus EBY plus EBX. Now taking negative on that side gives us Q due to this relation, and it is EBX minus EB alpha minus EBY. And I think I have messed up on anything. It seems correct. Just a second. I realize now that what I have done, I have written this thing here only, as you can see. No, I'm bullshit person. Is EBX, again I'm doing same mistake, EB alpha plus EBY minus EB what? X. Now let's try to describe this term, what has happened right now. So basically this is what has happened. So basically this is binding energy finally minus binding energy initially. Now binding energy is basically here is energy released. So energy released is energy released in making alpha plus energy released in making y minus energy released in making x. So that's why this term justifies. Now in term of delta mc square, delta m into c square is minus of eb. If we substitute it here, we get m x minus m alpha minus my into c square, and this is it, at least for alpha reaction. Here we obtained q in both terms using delta h. So in this thing, in this whole shit, there are only three major laws which can make your life simpler in a lot extent if you know thermodynamics, not nuclear reaction. Delta fh is minus eb, delta mc square is delta fh, and q is minus delta rh. Just these three things, and things are very simpler. And let us name them as law 1 2 3, right? Because we are going to carry out more, like we have done alpha reaction, we will do beta minus beta plus and that k capture one as well. So let us explain that why these laws are true. First of all, this is because this is due to definition, because eb is energy released in formation of one nucleus. Delta fh is energy required to make one nucleus. Okay, like basically energy content of a reaction, difference in energy content of a reaction. Delta fh is difference in energy content of a reaction. This is justified by energy content of product minus same thing I was telling you above, and this is also justified by reaction 1. Q is energy released, delta h is energy difference in energy content of a reaction. These are three laws of it. So let us proceed on our beta minus reaction. In beta minus, what happens is that that let's say a atom like Z, not A, X, Z A, it decomposes to X, Z plus 1 into A plus beta minus, and beta minus is electron, so anti-neutrino particle is also released. Anyways, nothing of our concern. So we're about to write its what energy content thing. So law number 1 First of all, let's say it's a kind of question like we have to find in both ways. So first of all, let's find in binding energy form. For binding energy form, we would be needing law 1 and law 3. So law 1 says that delta FH is minus EB. So minus E of beta minus E of beta minus E of, let's say it's Y, plus E of X is what delta RH, which is again minus Q. So EX minus EB. Okay, I'm again and again doing same mistake. EB plus EY minus EX is Q. This is product minus reactant, but I don't want you to learn anything else other than this reaction, these three things, these three laws. Okay, and now in terms of mass, if you can relate, we can directly write in them in this form, or we can directly use, okay, like delta mc square is delta fh, so delta m of reaction c square is delta rh, as we can say. It's a kind of analogy, and even the way I've justified this, I can even justify it because the sum of mc square is energy content at final minus sum of mc square is energy content at initial, and those difference of that gives delta h. So minus mrc square is something something delta r sorry q. Now there is one thing, what is this mx m alpha my? These are mass of nucleus. These are mass of things. Now let's simplify so that we can convert it into m naught form. Mass of nucleus is m naught, means molecular mass. Molecular mass of x minus mass of electron. How many electron? Z electron, as we have said. Minus m alpha is m naught of helium minus how many electron? Minus, I guess, 2 electrons. Minus 2 me, and minus m naught of y minus z minus 2 me. These two gets cancelled, and instead of that we can simply put m naught. And similarly in this reaction, let's first of all write its expression. So minus delta mr becomes negative of things, that means mass of x minus mass of y minus mass of beta minus, this is one electron precisely. So what is mass of m is m naught of x minus m naught of x minus what? Mass of z electron minus m naught of y plus z plus 1 mass of electron. Oh, here it would be plus. I'm sorry. Minus m of electron. This gets cancelled. Sorry, not this got cancelled. And here instead of anything we can put m naught. So this is it for beta minus and alpha. Let's come to beta plus. So in beta plus, this camera is bullshit. X Z A, it gets converted to x z minus 1 a, sorry, y, plus a positron electron plus a neutrino, which anyways we don't want, like nothing to do with it. Okay, now let's write first of all in term of binding energy, and I think binding energy is pretty lame now. Final minus initial thing done. Now let's write mass of initial products m of x minus m of y minus m of electron plus is q. into c square, of course. Now m of x is m naught x minus z times m electron minus m naught y plus z minus 1 times m electron minus m electron. And here wonderful things that happen is a factor of minus 2 me is there. Okay, this is it for today's video. And for k capture, it's similar to kind of it absorbs electron, proton plus electron. Okay, let's do it as well. X z plus electron, it gives x z minus 1 a, and since here it's electron, so here might be anti-neutrino, so here it is neutrino. Okay, and looking forward for your comment so that you can write energy of this reaction in terms of all this thing. Thank you for today.